Welcome to ClickMyProject.com. Project title: Mobile Data Gathering with Load Balanced Clustering and Dual Data Uploading in Wireless Sensor Networks. Now, see the abstract of our process. Cluster-based wireless sensor network is created with a number of sensor nodes and the energy-efficient cluster head selected in the network. Then, the mobile collector called a sensor collects the data from each cluster head and transfers data to the base station. The proposed load balancing reduces the delay and the replacement mechanism will change the cluster head if its energy is lost. Along with the routing procedures, the above mechanisms, that is the load balancing, cluster head election and the replacement mechanisms, give reliable result in the performance of the network. Now see the flow diagram. First the network is formed with the number of sensor nodes, then the cluster is going to be formed it with the cluster head. If the cluster head energy becomes high, then it performs the replacement mechanisms. That is, the cluster head is replaced with the another node. If no means the routing process is done. That is, the data is going to transfer. The mobile collector introduced in the network and it checks the availability in the cluster head. If it available, then the cluster head transfers data to the mobile collector, or else it performs the routing process to find the availability of data. After the mobile collector collects data, it transfers to the sink and the performance is analyzed here at the end. Let's see the running procedure of our process. First, go to the directory where we have the code. Then to run the code, type ns space filename.tcl. Here the number of nodes is created and for each and every node the position and the energy is updated. So only we get the result of each and every node positions and its energy, because we are going to select the cluster head based upon the energy. So only the energy is updated in the entire network. At time means the simulation time. So at each and every seconds of the simulator, we can get the location and the energy. This is the animated window, that is the nav window. Here only we see the simulation result. This is the number of nodes, the 50 sensor nodes. To run the simulation, click play button. Here is base station is placed and the sensor is placed here. This is the each and every clusters. Then the cluster head is selected in the network. The sensor moves near the cluster head to collect data from that. It checks the availability. Based upon that only it moves to near the cluster head and it collects data. So here the sensor that comes near the cluster head and the data is transferred to the sensor from the cluster head. After it collects data, it goes to another cluster head which has the data. So it moves upon to the next cluster head that having the data. So here this cluster head transfers data to the sensor. Like that, it moves near all the cluster head and collects the data. Now it crosses across this area and going to collect data from this cluster head. Then it moves upon near this cluster head and it collects data. At the time, each cluster head collects data from its members, cluster members. After this collects data, it goes to the all cluster head that is available in the network. After it finishes the connection, it transfers data to the base station. Here, the cluster head energy is minimized, so only the cluster head changes, that is, this power is changed to this as cluster head. After it collects data from this, the overall network data are transferred to the base station by the sender. So it moves near the base station and gives the all data that collected from the whole network. That is each and every cluster head. Now here we can see that it collects the house data and it moves near the base station. So like we see the communication ends. The collected data are transferred to the base station. To see the graph results, back to the terminal window and type gnu plot graph name dot plot. This is the graph for the packet delivery ratio. Here the sensor nodes is compared with the packet delivery ratio. So in x-axis the number of sensor nodes are varied and in y-axis packet delivery ratio is found out for each and every node. So the existing system is represented in the red color and the proposed system is represented in green color. Here we can clearly see that the existing system has less performance than the proposed system. Like that, we see the another graph as the command. Here is the throughput graph. That is the number of sensor nodes is calculated throughput. Same as the x-axis is represented as number of sensor nodes, and in y-axis the throughput is calculated and plotted. It is calculated in megabits per second. The existing system has less throughput than the proposed system. Hence, we increase the performance of the overall network.